Your wrist flicks the air like a sail catching wind. We step on hot tiles where the ocean ends. Palm fronds cut the light into moving lanes. I don't know your name, but I know your pace.
Mr. David here.
Welcome. Let's look at this Kara Trial Examination 2026 Chemistry Paper 1. Question number 1. Identify the Bunsen burner. Identify the Bunsen burner flame most suitable for heating in a laboratory. Give a reason for your answer, which we usually use non-luminous, and we have several reasons. One of the reasons is that it produces more heat when you compare with the luminous flame. So it produces more. It is the non-luminous flame. It produces a lot of heat and does not produce soot, which makes apparatus dirty. Therefore, it doesn't produce soot, which makes or which dirtify the apparatus. Therefore, the non-luminous flame is the most suitable flame used in the lab. Incomplete combustion of laboratory gas may result in air pollution, assuming the laboratory gas is mainly butane. Write an equation to illustrate this. Incomplete combustion, so let's have butane. Butane is C4H10. So when it is combining with oxygen, that is burning, incomplete, the key word is incomplete. So incomplete does not produce carbon 4. Instead, it produces CO, carbon 2, which is a pollutant. Therefore, it is going to form carbon 2 plus water. You need to balance the equation for you to get the complete marks. Therefore, this is the balanced equation to make work easier. Use dots and cross to represent electrons. Draw the structure of phosphoryl chloride. Phosphoryl chloride is here. It has drawn for you. So you see we are going to have phosphorus, oxygen, and 3 chlorides. 3 chlorides. Obviously, we will have a covalent bonding. Covalent, then there is dative. So let me take you through very slowly here. So we will have phosphorus at the center. Phosphorus is atomic number 15, therefore it has 3 electrons outside. So that is 2 to 8 to 5. That is phosphorus. Now for chlorine, it is 2 to 8 to 7. So it needs 1 to be stable. So these ones has to share. So this and this, they will share the electrons. So phosphorus will provide 1 electron and chlorine will provide 1. So they share and it is complete here. Phosphorus will provide 1 electron, chlorine will provide 1, and it is stable. Chlorine will provide 1 electron. Phosphorus will provide 1 electron and it is complete. Now let's come to oxygen. Oxygen is 2 to 6. It lacks 2 electrons to be stable. Now phosphorus, it had 5. It has given chlorine 1. It has provided 1 for sharing, 1 for sharing, 1 for sharing. So 2 are remaining here. Here we are having 2 for phosphorus which are remaining. Here for phosphorus. So this phosphorus, it will give the 2 to be shared. It will give all of the 2 to oxygen, and that's where now dative comes in. Now you see this 2 for phosphorus is taken, is shared inside here with chlorine, with oxygen and phosphorus at the same time. So this is dative, and the rest is and these are covalent. sulfur and oxygen belong to the same group of the periodic table. Explain why sulfur exists as a solid at room temperature while oxygen exists as a gas. So you remember sulfur S8 and you know oxygen is S2. Now that is the reason. That is the reason. So sulfur is an octaatomic. Octa means 8. Octaatomic. It has 8 atoms combined together. While oxygen is a diatomic. Oxygen is made only with 2 atoms. Therefore, sulfur will have a stronger van der Waals forces of attraction. It will have stronger van der Waals forces compared to sulfur. Sulfur is an octa. It has 8 atoms combined together. Therefore, the force of attraction, that is the van der Waals forces, are likely to be very strong when you compare with that of oxygen. That is why sulfur is a solid in room temperature, and while oxygen is a gas, yet they are in the same group. Distinguish between empirical formula and molecular formula. You know the difference? Here is the difference. Empirical formula shows the simple whole number ratio in which elements exist in a compound, while molecular formula shows the actual number of atoms of each element in a compound. That is it. When a certain mass of hydrocarbon was burnt in excess air, 0.54 grams of water and this one of carbon dioxide were obtained at standard temperature pressure. Determine the empirical formula of the hydrocarbon. So here first you need to get the mass of this carbon dioxide using this. You know 1 mole you can get in terms of moles. And we know 1 mole represented the RFM of carbon dioxide. So this 1 mole is actually carbon dioxide, which is equal to 44 grams. Now we can as well get in terms of grams. You can say 44 grams is equal to 22400. That is in terms of grams. This one was in terms of moles. What about 37.16? How many grams will it contain? Now we will have the mass for carbon inside there, for carbon dioxide. Now once we have this mass, again we need to get now the mass for carbon only. So let me explain this, what has happened here. So the total mass for water was 0.54, but in water what I need is hydrogen. So hydrogen out of water is, the total is 2 plus 16, which is 18. The RFM is 18. Therefore, I need oxygen, hydrogen, and that is 2 over 18. That's where we have 2 over 18 of the mass. That is gives me the mass for hydrogen. Then in this one, I have converted this mass here is for CO2. But in CO2, I don't need oxygen. What I need is carbon. Carbon is only 12, so it is 12 out of the total for 2 times the 0.7, that is the mass, and it will give us 0.02. And that is, what is that? I think there's an error here. So this one is supposed to be 0.06. That is for carbon, and that is how now you get the carbon, the hydrogen, which will give you this, and then you get the empirical formula here. I hope you have understood what I have done. Ammonia gas is prepared in the laboratory using ammonium chloride as one of the reagents. Write a balanced chemical equation for the reaction. A balanced chemical equation. That is the balanced chemical equation for the preparation of ammonia in the lab. Dry ammonia gas is collected in the lab using upward delivery because we know ammonia is less dense than air. It is less dense than air. Aqueous ammonia is prepared in the laboratory. We usually use the funnel. Why do we use the funnel? We use the funnel to increase the surface area of absorption. We use the inverted, that is a purple in the water through an inverted funnel. This is the funnel to increase the surface area for the solution of the gas, because we know ammonia is highly soluble in water. Actually, in Form 3, we were told that it forms a fountain because of the high solubility in water. State Gay-Lussac's law. Gay-Lussac's law. You remember the Gay-Lussac's law? Those are the things you need to remember. It says under constant temperature and pressure, when gases react, they do so in volumes that bear a simple ratio to one another, and their products if gaseous. And their product if gaseous. If they are in gaseous, that is what called Gay-Lussac's law. $25 of ethene gas is ignited in 60 centimeters cube of oxygen, gas room temperature and pressure. Calculate the total volume of oxygen at the end of the ratio. Now we are using now the Gay-Lussac's law to apply here. Now we have ethene reacting with oxygen. Of course, it is going to form carbon dioxide plus water. But we have been told here the volume is 25, the volume here is 60, right? But now you need to balance this equation. For you to use the ratios, the simple ratio, you need to balance the equation. If the equation is not balanced, the Gay-Lussac's law is not going to work. Very good. So because of time, I want to make it very fast. Now you can see we have balanced the equation here. Oxygen has 3 moles. This one is 1 mole, this one is 2 moles, and this one is 2 moles. Therefore, if this one was 60, you say 3 is equal to 60. What about 1? So it means the volume for ethene was 20 centimeters cube using the Gay-Lussac's law. This is where the Gay-Lussac's law is used. Now we can get the volume for carbon 4. Carbon dioxide produced was, if 3 is 60, what about 2? It gives you 40 centimeters cube. You see that? But now the question is, calculate the total volume of gas at the end of the reaction. So at the end of the reaction, we now remember we add 25 centimeters cube of ethene, right? We add 25 centimeters cube of ethene at the beginning, but we have used only 20 from the Gay-Lussac's law. From the calculation here, we have used the 20. So it means there is 5 centimeters cube of ethene remaining inside, which is unreacted. And at the end, we have 40 centimeters cube of carbon dioxide produced. So the question is, what will be the total volume? So the total volume of the gases at the end will be 40 plus 5 the unused ethene. And that is where we have 45 centimeters cube of the gas of the mixture at the end of the reaction. In Kenya, trona is obtained from Lake Magadi. Trona is a double salt with a formula. This write an equation to show thermal decomposition of trona. Thermal decomposition of trona. That is the thermal decomposition of trona. Describe how sodium carbonate is used in softening a sample of water containing calcium chloride. You add sodium carbonate to the sample of water to obtain calcium carbonate as a white precipitate. As a precipitate, you filter the precipitate and you get the water that is soft. So once you filter that, you have removed the calcium which was inside the water. and that is how it is removed. Ethane gas can be prepared in the laboratory by reacting salt of a carboxylic acid with soda lime. Write an equation for the reaction. Ethane. So you need to remember how ethane gas is prepared, how ethane is prepared, how ethane is prepared in the lab. Those are the things you need to remember, the reagent used. So we use sodium. This is the soda lime. This is the soda lime we are talking about. And if we want to prepare ethene, then remember sodium propanoate. If we are preparing ethene, we use sodium propanoate. If we are preparing propane, we use sodium propane, that is 3-butanoate. We will use sodium butanoate. So this is the equation. This is sodium propanoate reacting with soda lime to give you sodium carbonate and ethane gas. And this is the diagram. The gas is collected over water method because it is almost insoluble in water, or you can say it is slightly soluble in water. When 1 mole of ammonia chloride dissociates on heating, the enthalpy change of reaction is endothermic, as you can see here, positive 176 kilojoules. That is an endothermic reaction. On the axis here, draw a labeled energy level diagram for the thermal dissociation of ammonium chloride. So the keyword you need to remember that this one is an endothermic because you can see this one. So if it is an endothermic reactions, you should know that the energy for the products, is higher, is more than the energy for the reactants. Therefore, that is the keyword. That is the keyword that you need to know. So these are the reactants, and we expect the products to be higher because endothermic reactions, that is how it behaves. Endothermic reactions, that's how it behaves. If it is exothermic, the energy of the product is less than the energy of the reactant. The energy of the reactant is higher than the energy of the products. Calculate the enthalpy change that occurred when 10.7 grams of ammonium chloride dissociates completely. Now you need to get the RFM, the relative molecular mass of the ammonium chloride, and that is this one here, ammonium chloride. It has been provided here. Remember, the chemical formula for ammonium chloride is, so you need to know that. An acid solution T was prepared by mixing 50 centimeters of 1 molar hydrochloric acid with 50 centimeters of 2 more hydrochloric acid. Calculate the volume of gas produced at room temperature when solution T reacts with excess zinc metal. Excess zinc metal. Alright. So we needed to get the number of moles of mixing of 1 more hydrochloric acid and 50 centimeters of 2 more hydrochloric acid. So this is the number of moles of 1 molar, and this is the moles of this. So you get the total, that is the sum. This is the number of moles of HCl. Now write the equation. Zinc plus this one gives you zinc chloride plus hydrogen gas. So the ratio is 1 to 2. So we know the number of moles of HCl is this one, and that is 2. We will ask what about this one. Therefore, we need to get a half. A half of these moles will be the moles of zinc. This is the moles of zinc. So 1 mole of what? Hydrogen gas, because now the moles, because this is the moles of zinc, which is 1, also the moles of hydrogen is 1. Therefore, this is the number of moles of hydrogen as well. So the question was calculate the volume of gas produced at room temperature. So 1 mole of any gas at room temperature is 24 dm cube. We will ask this moles of hydrogen will be how many? And that one will be 1.8 dm cube. Okay, 1.8 dm cube. Propyne reacts with the 2 moles of hydrogen chloride gas to form an organic compound Z. Propyne reacts with 2 moles of hydrogen chloride gas to form an organic compound Z. Write the general formula for the homologous series that propyne belongs to. Draw and name the structure of compound Z. The general formula for propyne, because it's CN H2N-2. Draw the structure of the compound. The structure is here. This is called 2,2-dichloropropane, or it can be 1,2-dichloropropane or 1,1-dichloropropane. So if you need an explanation, maybe let me explain what's happened. Yeah, so we have propyne. Propyne, that is 3 carbons. Therefore, it is this is. So for this one, we will have 1 hydrogen here, and this one we will have. So when you react with the 2 moles of is it hydrogen of HCl? Is it HCl? 2 moles of hydrogen chloride. Okay, HCl, yes. 2 moles of hydrogen chloride. What happens is the triple bond will break twice. Right? So the first one, the first HCl will break the triple bond to form C2. Then we will have the hydrogens which were here. Then now this chlorine, one of them will combine and be here, and we will have hydrogen here, and there was another hydrogen here, this one, and the new hydrogen now. Where are we getting this hydrogen from? It is from HCl. So this breaks, we have this and this, it combines this. Now this one is called, how many chloride we have? This is chloropropene. This is chloropropene. Now when you add another mole, because there were 2 moles, it breaks this HCl, it breaks this bond again to form C, then reduce the hydrogen which were there, take them back. There was chlorine here. Now there was hydrogen, there's another chlorine here, there's another chlorine. Now the new hydrogen, now this one will combine here, and this one will combine here. So it can be 1,2, it can be 2,2-chloropropene, or this chloride can join in the first one, so it can join anywhere. That's why we have the 3 names correct, or these names are correct, depending on how you drew the 3 drops of bromine water were added to compound Z. Stated the observation made. Compound Z. Our compound Z is 2,2-dichloropropane. So what happened when you do that? The yellow bromine water remains yellow because this one does not affect that. The setup below shows how nitrogen 1 oxide gas is prepared and collected in the lab. Study it and answer the questions that follow. Nitrogen 1. Describe how nitrogen 1 oxide gas is obtained in the round bottom flask. Ammonium nitrate, when heated, undergoes thermal decomposition to form nitrogen 1 oxide gas and steam. Write the equation between nitrogen 1 and the copper tannings, and that is the equation. Therylene is obtained by condensation polymerization. One of the monomers used in the formation of therylene is ethane 1,2-diol. Draw the structure of the other monomer used and give its UBAC name. This is the other monomer, which is benzene 1,4-dicarboxylic acid, or you can simply say benzene 1,4-dioic acid. That is the ring which is used with the ethane diol. State 2 uses of therylene. Therylene, it is used in textile industry, making belts, seats, ropes, fishing nets, etc. Electric cables, wire, insulation, plastic bottles and sheets. That is the uses of therylene. Explain one disadvantage of the continued use of therylene. These ones, they are non-biodegradable, therefore they cause environmental pollution. The below shows the colors observed when 3 drops of universal indicator were added separately to solution WXY. Select a solution that can be used to illustrate the acidity property of aluminium oxide. Aluminium oxide, acidity property of aluminium oxide. Remember, aluminium oxide is amphoteric, so it behaves as an acid as well as a base. So if it is red it is an acid. Red it is around 1, 2 to 3. Violet, yellow is around 4, 5, 6. Violet is 12 to 14. Select a solution that can be used to illustrate the acidity property of aluminum oxide. Now, being an acid, then it has to react with the base. So solution W is the correct answer because these are bases. So the aluminum oxide should react with a base to show the properties of acidity. State one advantage of using a universal indicator over the other commercial indicators. What is the one that is one advantage? It shows the strength of acids as well as the strength of bases. It shows the strength of acids and bases, the strength, while the commercial indicators shows only the acidity or the basicity. This one is able to show the strength. Yeah, the commercial indicators will only tell you that this is an acid and this is a base, but it cannot tell you which one is stronger, which one is a weak acid. But a universal indicator can show the strength, can show that this is an acid, and as well as its strength. Describe how pure dry sample of lead 2 chloride can be prepared in the lab. Lead 2 chloride is an insoluble salt, therefore we are going to start with the metal and dilute hydrochloric acid. Correct. For you to prepare a salt, before you prepare it, first know whether the salt is soluble or insoluble. Add excess lead metal to a beaker containing dilute nitric acid. That is correct. To form, we are going to form lead nitrate. So add excess lead metal to a beaker with dilute nitric 5 acid. Somebody could say, where is the red nitric acid? Where do you get nitric acid? You need to use nitric acid because if you use sulfuric acid, lead will form a precipitate. If you use HCl, again the one provided here, you will form lead chloride, which is a white precipitate already. So you have to use nitric acid first, then you stir. We are now forming lead nitrate. Filter, then there is no effervescence. Until there is no effervescence, now you add the filtrate. The filtrate now is lead nitrate. You add it to a beaker containing dilute hydrochloric acid. That is very true. Now the chloride will combine with the lead in the nitrate, forming a precipitate, which is lead 2 chloride, which is a white precipitate. Now you need to filter the white precipitate. You get the filtrate and the residue, and our residue is what we want. Then you need to wash the residue and dry it between filter papers, and you have formed you have prepared the salt.